took a step back from the bell ringer. We're going to show you the derivative of cosine. I told you that yesterday. I just said it is because I said so. We could look at a more of a graphical analysis of it, but I'm actually going to show you the algebraic proof. And anytime I'm proving a derivative, it goes back to the limit definition, because that's what a derivative is. Now, the thing that gets difficult about this is having to break up that h inside a sine function. So we have to use a trig identity to do that. Does everyone remember, even if you don't remember the actual identity, that there is a sum or difference identity for sine? And so we have sine of x plus h. That is equivalent to sine of x cosine of h plus cosine of x sine of h. You remember seeing that, right? With a little bit of rearranging, I can factor out a sine of x in these two pieces. Factor that out, and I get sine of x times cosine of h minus 1 plus cosine of x and sine of h. Why would I do that? Well, this limit right here, does that look familiar to you? And this limit right here, does that look familiar to you? Whether those are familiar limits that we have memorized. And so this limit is 0, so this whole piece is 0. This limit is 1, so I get sine of x times 0 plus cosine of x plus 1. So the derivative of sine of x is cosine of x, if we did it over definition. No one ever wants to do that, right? That was pretty horrible. So you can imagine this is what we just want to memorize. We just want to memorize the derivative of sine is cosine. And that'll save us a lot of time. We are also going to end up memorizing the answers you got here. So this was your bell ringer. I had you find these derivatives using the quotient rule. I told you the derivative of sine. I told you the derivative of cosine. And so we can use the quotient rule and some trig identities to find these two derivatives. Again, though, you can imagine secant and tangent are common enough. Those will be derivatives that we will just memorize. But for today's so the derivative of secant of x low is the derivative of 1 minus I d low, and what's the derivative of cosine? All over cosine squared of x, which is sine of x over cosine squared of x. There isn't anything wrong with that, but that is equivalent to sine of x over cosine of x times 1 over cosine of x. And what is sine of x over cosine of x? And what is 1 over cosine? So this is tangent of x times secant of x. You will actually memorize that the other way. Secant of x times tangent of x is the derivative of secant of x. So that's another one I'm going to memorize. The derivative of secant of x is secant x tangent x. Doesn't matter. You can memorize it any way you want. You probably will end up memorizing this. It's the way it's written. Tangent is sine of x over cosine of x. So the derivative of tangent is low d high. What's the derivative of sine? Minus high d low. What's the derivative of? On the top, I get cosine squared plus sine squared. What is cosine squared plus sine squared? So the derivative of tangent of x is secant squared of x. You remember me telling you at the end of this chapter we're going to have a master exam? You're probably starting to figure out what's going to be on it. There's a lot of stuff in this chapter we're going to have to memorize, and so that's going to be a good portion of your master exam. So here's some, well, actually, two of them are the ones we just found, and then some more. So we're going to find all of the derivatives today. I went through two post-school groups. You can see how the others would talk about very similarly. So the derivative of tangent of x is secant squared of x. The derivative of cotangent of x is negative cosecant squared of x. The derivative of secant of x is secant tangent. The derivative of cosecant of x is negative cosecant of x, cotangent of x. Just for a quick trick for you, all of the functions that start with cosine, cosecant, cotangent, all of their derivatives are negative. Just to help you remember which ones have negatives in the derivatives. The derivative of cosine is negative sine. The derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant of x, cotangent of x. The ones with co in front, yeah.
Yeah.
Doesn't help you memorize everything, but it will help you memorize which ones have negatives and which ones don't. You do. You need to memorize them. They will be on your mastery exam.
Which should be it.
Yeah, it'll be right around the time of this test. In fact, if I remember correctly, this test will be 50 points of the test will be the mastery exam. So you get automatic 50 out of 50 on it. And then the other 50 points will be exam. But a good portion of the material in this chapter is derivatives and derivative rules. We will master those. Because if you don't, you will really struggle on the AP exam. So the master exams have pulled out the most important information. The things that I would say you cannot pass the AP exam for this stuff. Master it before you get there. It works great. In fact, at the end of the year last year, we took the we had 3 master exams. We took all 3 of them as an exam. Like you couldn't retake, we took all 3 master exams together. You'd already mastered them throughout the year. And there were about 8 people who did well on that test. And there were about 8 people who didn't pass the exam. So if you don't know this, memorization stuff. It's memorization stuff. It's the stuff you can't do well on AP. If you don't know the basics. So now we know the rules, and now you know the rules. So if you're doing a homework problem, you can just use the rules.
But why can't you just put the 3 for the x? So it's 3x squared and the derivative of tangent.
Because that's not how products work. And we looked at that when we did something like this. It was more complicated. The one we did was more complicated. I know that's x to the 5th. Right? You agree that's x to the 5th? And so the derivative of that is 5x to the 4th. No question about it, right? This derivative is 2x, and this derivative is 3x squared. Is that the same thing? Yes. So just end up here. That derivative rule. What is it? Remember on the first day I said it's a glaring rule that's missing that we don't have. We can't just take the product of both pieces. That's the reason why. So you have to go product. So we're going to do left times the derivative of the right. Now, yesterday you would have had to do a quotient rule to do the derivative of the right. And if you have to, you have to. But I don't think I have to anymore. What's the derivative of tangent? Any questions? Good. What's the next one? You agree it's definitely worth your time to memorize that derivative. Because that last slide, even though quotient rule is wonderful, it took us a minute to do the derivative of something. So it comes up often enough that we just cosecant. What is the derivative of cosecant? Negative cosecant cotangent. Since there's already a negative in front, positive. And the derivative of sine is I would not do any simplification of that unless there was unless I get on a multiple choice question and that's not an answer choice. You know what I mean by that? It's the only time I would pursue any simplification of that. You could change if you trig identities and stuff, but again, the only reason I would do that is if I've done a multiple choice derivative and that's not an answer. So the derivative of cosecant is negative cosecant cotangent. This one. Good. Remember, if there's a plus or minus in between, it becomes a bigger problem because then I can't just take the derivative of each. Okay, find the derivative of this weird thing where c is a constant. Why do I need to know that c is a constant? How do you take the derivative of a constant? Zero, right? So, a constant, like 3. 3 is a constant. What's 3 squared? What's the derivative of that? Still 0. For the derivative of a constant, you do not use a power rule. You just, that's why they had to say c is a constant, it's not a variable. So, the derivative. I'm going to do low d high. So what is the derivative of the top? Just 2x, right? The c squared goes away because it's constant.
I think it's like actually not a variable.
Right. So it's just, we don't know what the number is, but it's just some number. Where x is a changing quantity of a variable. Low, d high, high, d low, all over low. So I get 2x cubed minus 2x d squared minus 2x cubed minus 2x d squared. All over x squared minus c squared squared. Combining like terms on the top, the 2x cubes cancel, and I just get negative 4xc squared over x squared minus c squared. So when I do say do some basic simplification, that's what I mean. When I talk about terms, do things like that. The last one, you have 2 options on it. What are my 2 options?
You could more first.
Good. I could do algebra first and then the derivative, or I could do the derivative first and then algebra. I always would recommend algebra first if you can. I'll show you both how I got that?
Mm-hmm.
The 2x cubed times x squared. I'm not doing a derivative yet. You could.
No, okay, let's do the product.
I will do it that way too. But if it were me, I would do all the algebra I could do first and just use calculus. And I'm going to do it that way too. I'm going to do both. So the first way I'm going to do it is algebra heavy. The second way I'm going to do is calculus. It does depend on what the answer choices look like. This would be multiple choice. It very much depends on what the answer choices look like, how I would approach it to like 2x cubed times x is negative 2x squared times negative 6 is negative 12x cubed. And there's the 5x times everything gives me 5x cubed minus 5x squared minus 30x. There's one thing I can combine there. And then I can take a derivative. I would guess, if for some reason this were on an AP exam, that the answer choice would look like that. If it looks like that, you would want to do all the algebra up front. If for some reason the AP exam did decide just to test the product rule, what was that original function again?
2x.
This time I'm going to do it with no algebra up front, and I'm going to do a product rule with 3. Now you've seen me do one of those product rules with 3. Y'all know what I'm talking about. I remember yesterday. We said we could do a product rule with 3. We did the derivative of 1, leave the other 2 alone. So I'm going to do that. Or I can even FOIL the second one out and just do one product rule. You have lots of options on this problem. So I'm going to do the derivative of the first one, and I get 6x squared plus 5. And I'm going to leave the other 2 alone. Then I'm going to do the derivative of the middle one, and leave the other 2 alone. Derivative of the middle one is 1. And then I'm going to do the derivative of the last one, leave the other 2 alone. Talk about why I probably wouldn't choose this approach. Most likely the answer choice on the AP exam will be in that polynomial format. What would I now have to do if I had taken this approach? I mean, I got to multiply 3 different things out. When the other way, I just had the 3 at the beginning and done. So that's why I probably would do any algebra I could before I simplify. Now, if for some crazy reason AP had this as an answer choice or had an answer choice that looked like this, then you might take more of an approach like this. But I would always do what I did in the red part on this one. Works out nicer, looks prettier.
On the AP exam, how much time do you get for each problem?
On multiple choice, it's about 2 minutes a problem. It's actually a little different than that. The calculated part and the non-calculated part have different amounts of problems. If you look, on that handout I gave you on the first day of school, that looks kind of like a syllabus. On the back page of that, if you look, there's an AP exam set of information, and it'll actually tell you how many problems are on the on each part and how much time you get. So you can kind of see it's a little different on the calculated part, non-calculated part, but it averages to about 2 minutes. Now on the multiple choice, sometimes it's a little bit of an issue. Not like ACT though, you know what I mean by that? It's not as much of a time crunch as ACT. There is, you have to pay attention on multiple choice. Open response, I feel like you have plenty of time on open response. So you put 2 minutes per problem. So I feel like generally you have the time you need on open response. Open response, oh, by the way, I'm done. I'm sure that's your homework you have already had. It is accept. Now you can do your technique and also other than the open response is kind of weird. Those of you who haven't heard me talk about it, that's like interesting. Open response, you get two calculator problems first, and you get 30 minutes to do those 2 calculator problems. They're open response. When that 30 minutes is up, you have to take your calculator out, and you get the last 4 problems. You get another hour. So actually, you go back to the first 2. You just can't do the calculator. So for some reason, in that 30 minutes, you didn't finish the justification or something like that. You can always go back and finish the justification on this. You just take your